today we are going to talk about evidence and inferences, and to explore this idea, we're going to look at some mysterious footprints, some dinosaur footprints. It's possible that you've done this activity, especially if you had Ms. Linder in 6th grade, but now that you're an 8th grader, you're going to have a better understanding, even if you've done this activity before. So if you know what's coming, don't spoil it. Rely only on the evidence that you can gather. Yes, what's the date? 18. So, today we are tracking those tootsies. Have you ever tried to track someone down using clues they left behind? Muddy footprints, crumpled papers, or smudged footprints? Such tracks tell you many things about how the person moved, where he or she was going, or even how he or she was feeling. The skills you use to track people are like the skills paleontologists use to track ancient organisms. In fact, tracks left by ancient organisms are some of the major clues paleontologists use to learn about ancient life. In this activity, you will try to decipher puzzling clues left behind millions of years ago. You will learn the difference between evidence and inferences in the process. You will use the evidence and inferences to make scientific explanations for the clues that you observe. So the first thing we're going to talk about is some vocabulary. Evidence is facts, things that we can gather, observations gathered with our 5 senses: sight, smell, hear, touch, and taste. So in that first box for vocab, please define evidence observation. That first bullet point helps you out. Evidence is directly observable facts, things that are true no matter what. Like, it's a fact that my pencil sharpener is on this desk here. Nobody can disagree with that. I can directly gather my evidence, or I can indirectly gather my evidence. Direct evidence is things that I am directly observing with my senses. Indirect evidence would be things like footprints. I'm looking at them, but I'm using that as indirect evidence. I can also use indirect measurements, like a thermometer, to measure temperature. I can have qualitative observations that describe characteristics or properties, or I can have quantitative observations that describe an amount or a quantity. So if I look at those words there, qualitative tells me that I'm finding qualities, characteristics. Quantitative looks like quantity. I'm finding numbers, observations that I can describe using numbers. My inferences are the conclusions based on the evidence. It needs to be backed up by my observations. It needs to be relying on my facts, but it goes beyond what I can directly sense. So make sure that you have these vocab terms defined in that first part of the activity. This idea goes back to what science is and is not. Science is that collection of fact, but then we go past that. We have more than just a collection of fact. We use our scientific understandings to make inferences. And some of those inferences are true, and some of them may not be. We have to rely on our evidence to come up with our scientific explanations for what happened. Pause the video, let you guys fill in your notes. Alright, so now, let's figure out what we're doing today. Today's activity, what we're going to do is we're going to reconstruct happenings from an ancient past using evidence and inferences from fossilized footprints. We're going to form defensible scientific explanations, so arguments that we can defend with evidence. And then as more evidence becomes available, we will modify or discard our explanations. So the first thing, this first slide here, we are paleontologists and we have uncovered this beautiful bit of fossilized evidence. Your job now is to make observations. You should make 3 qualitative observations and 3 quantitative observations. Please stop with your observations and then we'll move on to the inferences in a minute. So I'm going to give you about 5 minutes to make observations and type them into your form. Remember, qualitative observations describe qualities, quantitative we describe with numbers. Alright, now that you've had time to make some observations here, I want to hear about it. Remember, our observations are facts, things that we can't argue with, things that we can directly observe. So what sort of observations did you make?
Blueprints are larger than the rivers.
Beautiful. The blueprints or green prints, these footprints are larger than those footprints. That's a fact. Now that might lead us to a conclusion, that might lead us to an inference that we'll get to in a minute here, but the fact is that the bottom footprints are larger than the ones on top. What else? Oh, what kind of observation is that? Qualitative or quantitative?
Qualitative.
Qualitative. That's a quality about the footprints. If I measured them and I said the green footprints are 10 centimeters and the red footprints are 5 centimeters, that would be a quantitative one, but I don't have that information. The qualitative observation is that green footprints are larger than red footprints. Corey? There are fewer green footprints than red. Beautiful. What kind of observation is that if I'm using the word fewer? It's actually qualitative because fewer is a quality. But if I counted them and figured out there are, I don't know, who counted footprints?
13. Yeah, 13 green ones and 25 red ones.
Beautiful. There are 25 red footprints and 13 green footprints. That would be quantitative observations because I'm describing them with numbers. But the qualitative one is that there are fewer green footprints. I agree. What else? We talked about the size of the footprints. We talked about the number of footprints. What else?
The footprints seem to be going towards the same direction.
The footprints seem to be going towards the same direction. Is that an observation? Is that a direct fact? No. That's an inference. They do seem to. I agree with you. Your inference is probably correct. But at this point, the evidence, what evidence can I take from that inference? If I back up. Help me out.
But they're going on the same like
So that they will intersect would be an inference. But the observation is I can say that those green footprints appear to be heading, relative to my slide here, they appear to be heading northeast. And then the evidence I can take is the red footprints appear to be heading southeast. That would be my direct evidence. And then my inference would be that they appear like they're going to connect, that they're going to hit each other. So now let's talk about some other inferences. That's a good inference, and it looks like that these paths will intersect. But I don't know that for sure. What if this happened and the red footprints happened at 10 o'clock in the morning and the green footprints happened at 5 o'clock in the evening? Footprints don't give us a time frame. What if it happened a million years apart? So I'm making some leaps of judgment here using my scientific knowledge and scientific understanding. But it's a reasonable inference to make because footprints tend to be left at about the same time, especially if they are preserved perfectly like these footprints are for our activity. What else? What other inferences can we make? Let's think about the size of the footprints. If I'm thinking about red footprints and green footprints, what inference can I make about the organisms that may have left those footprints? What do you think?
The size of the human.
Yeah. So specifically, what about the size of the organism? Yeah, so if I'm looking at this here, I can infer that the organism that left the green footprints is probably bigger than the one that left the red footprints. Not a guarantee. I could have a really big organism that just happens to have small feet. But if I'm relying on my scientific understanding and my scientific knowledge of other organisms, organisms that tend to have big footprints tend to be bigger than organisms that leave small footprints. What else? How about the spacing? So the number of footprints or the spacing of the footprints. What inference can that lead us to? Oh, Charlie. No, we'll be awesome.
Okay. That the green footprints or green backs that takes larger steps.
Okay, it looks like the organism that leaves green footprints takes larger steps because they're farther apart. Beautiful inference. Dawson, what were you going to add?
I was going to say that like they separated.
Oh, it looks like, which one? Yeah, those bottom footprints, it looks like the organism started running. That's an inference. What evidence do you have to back up that inference? The spacing. So we see with these footprints here that the spacing starts out pretty close together, and then they get farther apart. The direct evidence is that they get farther apart, but the inference is that I know when organisms pick up speed, they tend to have longer strides, so their footprints are spaced farther apart. So if I had to come up with a scientific explanation for what's happening here, I don't have a whole lot of evidence. What's one possible explanation for what's going on in this little snapshot? evidence to support that the green one's hunting the red one yet? Not yet. We'll get there. We don't have a whole lot to rely on. We don't know much about these organisms. We don't know that they interact, because right now their footprints are far enough apart. But let's move on. As Dawson alluded to, we're going to get some more information here. In position 2, now we have more information. As paleontologists, we've excavated our site a little bit farther, and we have more information about what may have happened here. So on your slide, or on your Word document, you should be going in and adding observations. I think it asks you for 3 observations and then 2 new inferences. Your inferences may be similar to the ones you had in the first slide, but they may be different. You may have changed your understanding based on the evidence presented. We'll pause this, and I'll give you a few minutes. So what new evidence can we add to our understanding? What do you notice now that we have this second slide here? The footprints, the pathway of the footprints intersect. I agree. Does that mean that the organisms interacted? No, that would be an inference. Now, based on what we know, it's a pretty good inference that we'll talk about when we get to our inferences, but our evidence shows us that the pathways cross each other. What else? What other evidence can we pull from this new information? What do you think?
The red footprints start to space out a little bit towards.
The red footprints start to get farther apart. So in this section here, the red footprints were pretty evenly spaced and close together, but now the red footprints are farther apart. What else? What else can we notice?
They like changed dramatically on pathways, running circles and stuff.
So the footprints are no longer in a straight line. When I looked at just the first set of information that I had a pretty linear path. And now my footprints are jumbled. They're no longer all facing in the same direction. Good observation, good evidence that I can pull. Any other evidence? Hit most of the big ideas here. What inferences can you make? How are we building our understanding of what's happening? What do you think?
They're probably fighting.
Oh, you are inferring that those organisms are fighting. Why? What evidence do you have to make back up that inference?
They're kind of jumbled in the same exact area.
Okay. The organisms' footprints are jumbled in the same area. So Dawson thinks that means they are fighting, because we know that when organisms fight each other, their footprints are no longer in a straight line, and they would be in the same spot. What else?
It's possible there was like a water area between water and
Oh, it's possible that there's a third object, that both of these organisms are interacting with something else. Maybe not with each other, but maybe they're interacting with something, like water or a food source. What else? What other inferences? So far I've heard 2 competing ideas. One, that we have some fighting, some eating happening, and another, that they are interacting with a third object. Corey, what do you think?
To me, it looks like the red box isn't like usually they run like through different directions. I think they branch off in different ways, so maybe they were trying to.
Okay, so Corey says they're not fighting, because if the green foot-printed organism was trying to eat the red-footed one, the red-footed one would have escaped. The prey likes to escape its predator. So you think that we have more support for the fact that they're interacting with a third object. Interesting. What's that? Oh, maybe they're on a cliff, but we don't see a cliff here. There's no evidence to support that there's an edge of the pathway here. It could be true. It could be that it was lost to history, that we didn't get all of the information from our paleontological excavation. Lots of different inferences we can make. Let's throw in our last piece of evidence, our last slide. We continue to excavate. And our final evidence, we've finished our excavation of the site, and we see this third position. On your Word document, you should be giving me observations, things that you noticed, direct things that we can cite about our third position here. And then we're going to talk about inferences and then come up with our scientific explanation. So right now, observations and inferences about position 3. Alright, even if you're not quite done typing it, I want to talk about it so we can finish our discussion and then I'll give you time to work to finish out this activity. What do you notice? What are some direct evidence, direct observations you can make? Charlie?
The red footprints stop and the green footprints continue.
In my third position, I no longer have red footprints. I only have green footprints. I agree. What else can we observe about this last position?
They did fight.
They what?
They did fight.
Oh, that's an inference. I agree with you that that is a possible inference I can take, but that's based on the evidence that Charlie stated, that I no longer have red footprints. So in our heads as scientists, we're trying to come up for why that might have happened. So an inference we could make is that they had a fight.
The footprints are spaced equally again.
If I look at my green footprints, they are now spaced evenly again, evenly and close together, whereas I saw they were close together, farther apart, jumbled, and then close together again. What inference might that lead you to?
That is walking.
That's walking away, that the organism was walking, it ran, it did something, and then walked away. So those are inferences we're making based on the evidence of the footprint spacing. What else?
We don't see a bird, so we get it. So when the footprints go off the bird.
What's that?
There is no another footprints when you get bird.
Oh, so these are single organisms. We don't have a herd of organisms. So the evidence is that we have two singular organisms. The inference would be that they are walking by themselves. Now it's possible that maybe these ones were just the only footprints that were able to be left because the ground wasn't wet enough for the rest of the organisms. Good inference. But the evidence is that we have two organisms and that we have one single organism leaving footprints in the end. Anything else? Any other observations that we want to make about this slide? Alright, so now tell me what happened. I heard Dawson's idea that they had a fight. What's another possible explanation for what happened?
The red one was able to dig or swim.
Oh, the red organism dug or swam. Tell me the evidence you have that it swam away.
There aren't footprints.
But do swimming organisms leave footprints?
Or like if it was a rock.
Oh, so that would require that maybe there's a body of water that's here that we don't have. Okay, that would work. Then yeah, maybe this one swam away because there's a body of water that used to exist over here. Why else would an organism not leave footprints if it didn't get eaten, but it doesn't leave footprints anymore? It could have swam away, or
The green organism could have picked it up.
the green organism could have picked it up. Maybe it's a mama and a baby, and they're eating something together, and then the mama picks up the baby and they walk away together. Maybe we rely on Dawson's idea of a fight, that they fought each other and then the green organism's carrying it away in its mouth. What else?
Maybe the red footprints flew away.
Maybe it flew away. I hadn't heard the swim away idea before, but that would work. Maybe it flew away, that they were fighting and then it flew away. So we have lots of things that point towards a fight. What else could have happened? If it wasn't a fight, if it wasn't a predator-prey relationship, what else might have happened? Think about some of our ideas from back at the beginning.
It could be like a flying demonstration. But maybe. And the green footprints are trying to protect it.
Oh, maybe the green footprints are protecting the organism that left the red footprints because they're working together to be safe from a third organism that was a predator. Interesting idea. So predator-prey or a protector, like mother-child relationship. I think there's one other possible scientific explanation that I heard in this class. A little louder.
The red footprints grew into the green.
Oh, that the red footprints grew into the green footprints. Not as much evidence to back that up, but it's a possibility. What about if they were both interacting with a third organism that maybe there was just a good food source here or a good source of water, and then they both just left? that it happens at a different time, because we don't know for sure that these are happening at the same time. It could be a couple hours apart. It could be days, months, years, millions of years apart. Probably not millions, it wouldn't have been preserved at the same time. But it could have happened at separate time slots, and they're just both interacting with one source here. Lots of different possible ideas, so your job now on your Word document is to find the scientific explanation spot, and you need to write the story about what happened. Your story needs to be based on the evidence. Don't give me the whole story of Arnie or something. Based on the evidence, what happened. Your story should be at least 2 sentences long. To give me a good explanation of what you think happened here, including that evidence, should take you about 5 sentences. So you have the rest of class today to finish up this Word document and click submit on it. And when you are done with that, some of you didn't submit yesterday's task, so go in and make sure that you've submitted the science literacy activity from yesterday. If you finish both of those tasks, then you may explore science news for students, you may work on work for other classes, up to you. And because it is Friday and you are doing independent work, you may listen to music as you work.